Hello and welcome back to the second session for Virtual Labs 2017. My name is Tiberiu Kovac and I'm a Microsoft Regional Director, and with me I have David Rodriguez, who's an Azure MVP. We are working together for Intelequia, and we are a Gold Solution Partner for Cloud Solutions and a Gold Partner for Application Development. As we talked about it last time, the agenda is quite simple. We are continuing our discussion, and now we are going to look at the cost estimation tool and at how can we do automation and how can we use auto scaling. So let's get started. First of all, I think everyone will have the same question: how much do we need to pay for the virtual lab? Well, this is not a very complicated question, but not a simple one either, because there are a lot of things that will influence the final price, like how many users do you have in your applications or for your virtual labs, how many of them are concurrent and they need to use the system at the same time, what kind of users, are there light users that are just needing some simple applications, or are they advanced users or heavy users where they need stuff like GPUs and such. Do all of them consume GPU or only some of them? Do you need high availability for your solution, or is okay if the application or the solution doesn't work for a certain time? Can you shut down during the holidays or not? So all those are questions that you need to answer before we can start looking at the numbers. And then as well some questions related to auto scaling. So when we talk about the concurrent user per time of day, then we can decide that, and we can do automation and make sure that we get more machines running during peak hours, or how many are working during weekends. If you don't have anyone working during weekends, or very few of them, you might actually be able to just run one single virtual machine and not having to pay for a lot of machines just to support the workload. Now, let's have a look at the Virtual Lab Cost Estimator tool. It is actually a simple Excel sheet, not simple, but it's an Excel sheet that will actually ask for your input, and you would have to specify what exactly do you want to use in your own environment. We are going to ask you about the kind of machines you want to use, and then we are going to ask you about the number of users and so on. And based on the machines that you are choosing, we can simulate different kind of numbers and give you different how much it will cost using different machines. Another thing that we would like to know from you is if you want to use a high available deployment or not. And then you can choose the number of users. So in this situation, if we assume that you have about 1,000 users and only 20% of them will access the application at the same time, and maybe out of those 1,000 users, 20% will come and work during the weekend, and the distribution is something like 60, 25, and 15 between light, medium, and advanced users, and you only work 320 days out of 365 days per year. Looking at all of those numbers and maybe putting into place the discount that Microsoft might give you based on the consumptions and other factors, we can do an estimation, and we can tell you that you might look at a yearly cost for this solution for 39,941 euros, which translated into dollars it would be about 44,678. So this gives you actually a quite accurate picture about the cost that you would have to incur running those kind of machines. Of course, this can be tuned up and down based on the number of machines, and there are a lot of things that can be changed. And you will see actually in the demo how all of those numbers can influence the final cost that you would incur for this solution. So now let's have a look at the demo and see exactly how this Virtual Lab Cost Estimators tool look like. Okay, so we are going to start in our GitHub repository, Intelequia/Virtual Labs, and here you have all the information about the virtual labs, including the cost simulator tool. So we can go down here and see in the table of content that we have the Virtual Labs Cost Simulator, and this will give me the documentation about what the Virtual Labs Cost Simulator tool it does and how you can use it, answering those questions that I mentioned a little bit earlier. And the result would be, based on what you have, will give you actually information on how much will it cost you. As I mentioned earlier, this is actually done as a simple Excel sheet, or maybe not as simple, but it is an Excel sheet, and we can have a look at it by downloading it directly. So when you download the Excel sheet, you'll get it on your machine, and then you can start playing with the numbers. So let me show you a simple simulation that we are doing in our situation. So we have about 1,000 users in our system. That's what actually is important at the moment. And let's assume first of all that we take a reference cost without auto scaling. So how much will we have to pay in case that we are not using any of the auto scaling features? So we have some reference data, and the reference data tells us how much will cost us actually a virtual machine, how many cores does it have, how much memory, if it has GPUs, how much will it cost per hour, and so on. And then we have some exchange data just to give us some approximate number. Again, this is a simulation tool. This won't give you an exact cost how much, but it will be a good approximation. And then we can specify what kind of machines do we need for each of the roles, like what do we need for the web role, what do you need for the gateway role, how much do we need for the connection broker, for the licensing role, and then how much will it cost each and every one of them. And then again, we have some prices here, based on the number of machines that are used. And here, as you can see, the one in yellow, it indicates the total cost for the session host GPUs and for the session host roles on the CPU, so depending on which one we are choosing. So if I choose, for instance, a different machine here, I would need maybe less cores, but the price at the end of the day would be almost the same. And then again, we have a file server because we are not using any file server at the moment. Then the total cost for this one, it's 0. We can look here and see exactly what are the Microsoft recommendations. Like per core in the session host, you'd need 1 to 10 users, and then you would need about 200 users per web or gateway. So that's how we calculate all the numbers in here. Now we can go into the inputs tab and then look at how much we can tweak with the numbers. And just let me go back and draw your attention to the total price here. The total price, or the reference price, would be roughly 140,000 euros, meaning that we are not using auto scaling, and we are paying for our system to be always ready to be used by the maximum amount of users. But now if we go and try to tweak a little bit the input, we are going to see how this will affect the final price. So for instance, we still have 1,000 users because that influences the final price anyway. But then we have different number of concurrent users. So if I'm assuming that the concurrent number of users it's only 20%, meaning that at any given time I won't have more than 200 users using the system, and maybe during the weekend I would have again about 20% of the users using the system, and then I'm doing the split of my kind of users between light, medium, and advanced into 60, 25, and 15. And I decide that my year should have 320 days. And then specifying exactly what's the distribution, what do I mean by a light user, medium user, and advanced user in terms of CPU/GPU usage, then we can do the simulation, and then we could see that the price actually at the end of the day would be 39,941, given that we have a discount from Microsoft for about 30%. If you have no discount, the price will be higher. If you have a higher discount, the price will be lower. You know the drill. Now, if we look at how we have the machines distributed, we could see that we have some machines that we are using like one machine all the time, or at least one machine, because the number of users it's specified in there. And then we can go up to 7 hosts actually, to be able to support the number of users into our system midday approximately. We can go back to the first tab, to the cost tab in here, and if we change the type of machines that we want to use for the host, we can observe two things. First of all, the price will increase a little, and the reason it increases is because we are going to use more machines, we are going to pay a little bit more, but the number of machines that are necessary, it's decreasing dramatically. So we have only maximum 4 machines that we need to use midday. So again, this will affect a little bit the price. It will be a little bit higher, but then we'll have the readiness for more users at the same time. Let me move that back to D13, for instance, and leave it there, and go back to this page. So again, looking at all those numbers, you can get an idea of what to expect from your system, and based on that, we can actually tweak our automation scripts. And with that, let's get back and talk a little bit more about automation. So as you could see, that gives you a very good picture about the numbers and how much it will cost you per year. Now let's look a little bit at the setup autoscaling. We are going to talk about autoscaling with the session host and then autoscaling the SQL database for logon storms. So let's have a look at how can we set up autoscaling in our system in the next demo.
In this demo, we'll see how we can automate the scaling of the session host as well as the database. This will allow us to save a lot of money depending on the number of users that are currently connected on. So we can scroll down here in the GitHub repo, and there are three different links. The first two ones are related to the automated shutdown and session host scaling, and the third one is about SQL database scaling. About the first one is refers just to create an automation account for shutting down the VMs for periods when the VMs are not being used. So this is suitable for example, holiday seasons, or just, for example, during some weekends that nobody is connected on. So we can just follow these instructions, and it's pretty easy just to automate this by following the instructions here. So we are going to see something more interesting in the demo, that is automated rest of session host scaling. Automated remote session host scaling allow us to scale the number of session hosts depending on the number of users that are currently connected to our system. So we have some pre-requirements. One is to set up to have our session host deployment with 2 or more session host servers in a collection. So it makes no sense to scale just one server, of course. Then the second one is to have remote internet access from the connection broker, outgoing connectivity to internet, because this is how the connection broker will be running a script that will need to connect to Azure management APIs just to shut down or turn on all the session host. Third one is the server will need to have a PowerShell 4.0. So, and since we have deployed this with Windows Server 2016, this is already covered. And finally, we have to step more. Sorry. So we need also we need to install the Azure Resource Management PowerShell module inside the connection broker. So let's start by doing this step in the connection broker. So to install the Azure Resource Manager PowerShell module, we just run PowerShell, open a new PowerShell console, and just run this module, that is install module Azure RM. We say yes. We say yes also to the second question. Okay, so now that has been installed, we can check that if we ask for the Azure commandlets, this is the first time it builds the help. We'll see all the commandlets available for just managing Azure from the PowerShell. Okay, here are all the commandlets. Okay, so let's close this. So, and the final prerequisite is to create an Active Directory application that will be the service principal, just that will be used by a script just to turn on and turn off the VMs. So in order to do that, we go to the Azure portal and just create a new application. So in order to do that, we just click on the Azure Active Directory and click on Apps Registrations. And we just click here, create new application registration. So we call this, for example, whatever name do you want. Choose the web app API type of application, and you just set up URL that uniquely identifies your application. This doesn't need to be a public URL or a valid URL, just one that will uniquely identify your application. We just create this, and so the script we will be using two things. One is the application ID and application key. So this is the first one, the application ID. We'll need to copy this for later use, okay, and store in a secure location. And second one will be the key. So we'll be here creating a key. Let's call this auto scaling RDS, and let's choose a duration of just 1 year for this key. And just by saving, this will show the secret, and know that this is the only time that will be shown here. So again, copy the secret that we'll be using later. The last part is just to give permissions to our application to modify our resource group, by turning on or turning off those session hosts. So in order to do that, we just click on the resource group, and on the access control tab, we just go here and click on add. We just select the contributor role and just find the application by typing the application name. We just click here and click on save. The next step is just to install the script that will be checking for the number of users connected to our connection broker. So this will be running, the script will be running inside the connection broker. So we need to log in the connection broker and save this script in one of those brokers. So the scripts are located here in Virtual Labs, deploy, located HA script under this script and this file. So let's take a look first to the configuration file, to XML. So the XML just have some Azure parameters that are the Azure tenant ID, that is just the guide of the tenant that our subscription, the application ID, that is the one that application that we just created them before in the previous step. We'll be using principal secret. We will not be using in this case certificates, so this is not needed at this point, but since we are going to use the application secret. And then of course the subscription name and the resource group name of where all the session host resides. And finally we will have some parameters here to parameterize how we're going to start turning on and turning off depending on the peak times that we can define here. Also the time and the local time depending referencing UTC, and also the number of sessions that will be used we will be allowed per CPU. So remember that Microsoft recommends between 1 and 10 users, 1 and 10 sessions per CPU. So, but you will need to measure that for your best depending on your scenario. And while also the minimum number of remote session hosts that we want to maintain, and as well as also other parameters for to force to log off the users. So for example, we can give 2 minutes to allow the users to save the work, and also allow to send a message to them. The second file is just the script that will be checking the number of users connected to our session broker, and will be turning on and turning off session hosts accordingly. What we will do now is to save these two files locally. So we can now go here and edit the XML file for parameters. So for the tenant ID, we just go to the Azure portal again and click on On the Active Directory, tap and click on Properties. From here, we can just go and copy the directory ID. That is the tenant ID. Second one is the application ID that we created before. So remember that we can go just to here in app registrations and click on application ID, on the application that we just created, and just copy from here. Okay, so let me type this here. Finally, the secret that appeared just one time before, and we need to save that in a secure location. Finally, just the current Azure subscription name as well as the resource group name. So for the subscription name, we just go to the subscriptions and select the subscription that contains all the deployment, and select the subscription name. And finally, the resource group name that contains all our resources, and this one. Okay. With that, we have set up all the configuration parameters. Click on Save. The final step is just to set up a scheduled task that will check for how many users are connected to our session host to run the script. So in order to do that, we go to Tools, Task Scheduler, and create a new task. From here, create a basic task. Let's call this RDS host scaling, for example. Click on Next, choose Daily, choose every 1 day, start a program, and just choose the script that we set up before. This is here, this is the script. We'll be choosing to run on this folder. Open the property dialog after finish. So it's important here. First one is to set to run whether the user is logged on or not. Second one is on trigger. Let's choose this and run every, for example, 10 minutes. Okay, so we'll be checking that every 10 minutes. So we click on OK and click on OK and save the scheduled task. After setting the scheduled task and I'm waiting for some minutes, we can just go and click here on the log folder, and we will see two files. One is the scale log and the usage log. So if we open the log, we see how the script is just working and checking for the number of connected users and the sessions open, and the current capacity that is available at this point per collection. So on the same way, we'll see in the usage. Well, in this case, we have two collections. We have one for remote apps, the other one for virtual host, and we'll see that how is the usage at this point. The next step is just to automate the SQL database scale up and down depending on the peaks and how many users or how the database is really performing. In order to do that, we just go to Azure portal again, and if we haven't done that yet, so we'll just add a new automation account that will help us on this task. We just click here and create the automation account. Let's give this just a name for IDS automation, and locate on the same location. Okay. Click here and click OK. This will take some seconds. Now that the account has been created, the next step is just to import the Runbook that will be working for scaling up and down the database. So in order to do that, we just go here and download the PowerShell script to our local system. I have already done that, so I just go here and create a new Runbook by importing that model. So choose the file, click on here, and just click on create. The next step is just to create here an asset with a SQL Server credential that the script will be using. So let's type here SQL Server credentials and just write the username and password. Click on create, and that's done. Let's go now and test our script. So in order to do that, we just go to our Runbook here and just click here on edit, where we can see the script that we have just uploaded, and click on the test pane. After introducing all the required parameters, we just check and click on here on the start button, and we can run a test just to see that the performance level has changed to our desired performance level. So we can also go here to check directly on the resource, on the SQL Server resource, to see that, of course, in the pricing tier, we can see that it's currently S1. Okay, that is the worst. Once that we have created our Runbook, we would like to associate a webhook to the Runbook, just to automate the scale up and down. In order to do that, we click again on the automation account, and in the Runbook, we just click here on webhooks. So what we're going to do is just to add a new webhook. For the webhook name, let's add it like, for example, a scale to, for example, S2. And we need to copy the URL of the webhook that we'll need it for adding the later to the alert. So here then we also specify the parameters, the required parameters that are the same, similar ones, well, the same ones that we added to the when we did the test. So server name, database name, the edition of database, and here the performance level that we want to scale to. In this case, as the name of the webhook is, let's put that as S2. The SQL Server credentials name, the asset name, and also the subscription name. Finally, the last two ones, the resource group name, where everything is stored, as well as the remote, so the Azure Automation, Azure Run as connection. Click OK and click on Create. In order to link now the webhook to the use of the database, we'll be adding an alert to the database. So in order to do that, go to the database resource, click here on alert rules, and add an alert. Let's call it, for example, this is the resource. Let's call it, for example, DTUs at 80%. So this fires when the DTUs are at 80% for 10 minutes. So let's, for example, the metric will be just, for example, set the DTU percentage and is greater than 80% over the last, for example, let's choose 10 minutes. So that means that if the database is at more than 80% during the latest 10 minutes, so okay, I want to receive an email, okay, to be notified, but also will fire a webhook that will be firing the runbook. If we click OK, so that's done. So in the same way, we can create the same alerts, similar ones for scaling down.
So as you could see, everything was actually quite easy to implement. If you want to look more about it in our resources, you have actually the GitHub repository at Intelequia/virtual labs. You can build your own environment. If you need any help or if you need any managed services, do not hesitate to call us or contact us at info@intelequia.com. Thank you very much for today, and I hope you enjoyed the session.